Hi everyone, I just give you back your exams. And this exam you have a great improvement. Yay! So if you can still remember last time, we only have 3 students between 70 to 80 and then the other student lower than 70. And this time we have a great improvement. The highest score is 94. The lowest score is 4. Average is 68.8. And we have 7 students get between 90 to 100, yes. And we have 1 student between 80 to 90, 2 students between 70 to 80, and then 2 students between 60 to 70, and then 5 students between 0 and 50. So, okay, good job. This is the weekly checklist. So, if your score is lower than 70, and then this is the requirement, okay? If your score is higher than 70, this is optional. So if you think like meeting me weekly really help you learn the materials, please continue to do that. Okay, everybody? Hi! So, yeah, this is a checklist.
Thank you.
You're welcome. Okay, so let's continue. By the way, on our course website, if you go to the bottom, you see the exam 2 solution. Okay, let me use this one. That is bigger. Okay. Hi, Cora. Come here and pick up your exam. Okay, so you see the exam 2 solution. You click that, and then you can see the solution. Please use red pen to make corrections on your exams. Okay, so if you have mistake on some parts, just write down the correction next to your answer using red pen or any other color pen. Okay, everybody? So after you finish that, you can go to the self-assessments. So here, if you haven't submitted your practice exam, please submit your practice exam here. And this is the exam 2 correction and record. So exam correction is 5 points. And you don't not only write down the final answer, but which steps you have mistake. And then you write down the correction from that step. Okay, everybody? Mm-hmm. And exam record is like a survey, asks you how did you study for the exam and how can I help you master the materials better. And some of you still miss homework and miss the practice exam 1 and miss the exam correction 1, exam 1 correction and wrapper. So please submit those as soon as possible. Okay, look at our schedule. We are Monday, April 10th, but we are already 2 lectures behind. So I'm gonna accelerate a little bit. So please focus in class and take notes. If you have questions, ask me, okay? So I might ask you to watch lecture video to catch up. But we are behind schedule. So I will move our homework 8 and quiz 5 to Monday. Okay, so you have the weekend to do it. We already covered 4.1 and 2.7. 5.1 we're gonna cover it today. Okay, so the weekend you can study that. And you can see with how many weeks left? 1 week, 2 weeks, 3 weeks, 4 weeks, and then the final. Our final is on Monday. You don't have much time to study for it, right, everybody? So I really hope that if you miss some homework, you missed practice exam 1 or exam 1 correction and wrapper, please submit them as soon as possible. Okay, everybody? Mm-hmm. All right, and also please keep like meeting me weekly. So I want to check on you. Yeah, we only have 4 weeks left. Please try your best to study hard, and I hope you can get a good grade. And don't forget that you can use the final exam score to replace one lowest midterm score. Okay? So if you continue to do well on exam 3 and the final exam, that will replace your first exam. So you can still get a good grade. So try your best. Okay, everybody? Mm-hmm. All right, so now let's take out 5.1 worksheets. So I gave it to you last time, and I also have like 3 copies here. So if you didn't take it last week, you can take it now. All right. Okay, so 5.1, exponential functions and their graph. Brief review of exponents. Please make sure you remember the exponent rules like your own name. So b to the m times b to the n is b to the m plus n. We add the exponent. Oh, I think you have it. Remember you have some notes on that one? Yeah, print it. All right, and then b to the m over b to the n is b to the m minus n. If it's division, when we combine, okay, with the same base, then we subtract the exponent. If it's a product, when we combine, we have the same base, and we add the exponent. If that power is in the denominator, that means we can move it up, but the exponent becomes negative. And the negative exponent is kind of flipped, reciprocal. So a over b becomes b over a. And a times b raised to the power m is a to the m times b to the n. And be careful. A plus b to the m is not equal to a to the m plus b to the m. You can only distribute the power if you have a product or quotient. Is that clear, everybody? And write it down. This is really a common mistake. When you see a sum or difference, okay, you cannot distribute the power. So be careful with that. And then b to the m to the n equals b to the m times n. We multiply the exponents. A to the 0 equals 1. Actually, 0 to the 0 is defined to be 1. Okay? So therefore, a could be 0, it could be not 0. Anything to the 0 is 1. B to the 1 over n is the n root of b. And b to the m over n is b raised to the power of m, and then take the nth root. Okay. So far, so good, everybody? Ooh, attendance. Thank you. Okay, so example 1. Simplify by using the properties of exponents. Okay, so here, let's see. Okay, do you see we have this exponent raised to this exponent? So what do? Do we multiply them or we add them? Multiply. So square root of 2 times square root of 2. Right? We multiply the exponents. What is square root of 2 times square root of 2? Square root of 4, which is 2. Yes. Right, everybody? And what is square root of 2 squared? Just 2, yes. The square root and the square cancel. So we just get 2. Is that okay, everybody? We're using the exponents rule. Okay, keep going. Part B. We have 5 to the 1 plus root 3 times 5 to the 1 minus root 3. What do we do to the exponents? Do we multiply them or do we add them? add them. Yes, everybody? We add them. So we get 5 to the 1 plus root 3 plus 1 minus root 3. What happened? Yes, we can cancel the root 3. What's the new exponent? Just 5 to the square. You see the 1 plus 1? Yes. What is 5 square? 25. Yes. So this is 25. Okay? So we want to get rid of the exponent. So this is what we need, simplify. Okay. And now, division. What do we do to the exponent? Subtract. So the base is 3. We use 3 plus pi minus parentheses 1 plus pi. The common mistake is students might forget about the parentheses. Okay? So parentheses is like your baby. Don't forget your baby. Okay, keep going. When we distribute, what happened? It becomes minus 1 and minus pi, right? The plus become minus. Ooh, what happened? The pi's cancel. Exactly. 3 to the second. Yes, which is 9. Good. Thank you. So far, so good, everybody? All right. So we keep going. Hi, Vienna. So here you go. You're welcome. Okay, next one. Yeah, it's negative. What does that mean? Yeah, exactly. We flip it. So we got negative 27 over 8 and then raised to the 4/3. Okay. Now we can distribute the 4/3 because inside this is like a multiply and then this is like divide, right? If it's multiply or divide, then we can distribute the exponent. If we have addition or subtraction, can we distribute the exponents? No. Okay, yeah. So let's distribute it. Okay, minus 1 to the 4/3. And then 27 to the 4/3. 8 to the 4/3. Okay. What's 4/3 mean? Well, the third is you take the cube roots, right? What's cube roots of negative 1? Square root of negative 1 is I. The cube root of negative 1 is... Okay, do you remember the graph of cube roots? Okay, everybody, line. X squared. X cubed. Square root. Like that. That's why we cannot have square root of negative number. The cube root is that, right? The cube root of negative 1 is negative 1. But, and then, okay, negative 1 to the 4th is 1. So far, so good, everybody? So this is 1. Okay, Quinton, do you know cube root of 27? It's a integer. Okay, what is 1 cube? 1. 2 cube? 2 cube. How about 2 cube? 8. 3 cube. 27. So cube root of 27 is 3, right? So, 3, and then 3 to the power 4 is 3 to the power 4 is what's 3 squared? 9. 9 times 9? 81. So 3 to the 4th is 81. So when you do your homework, try not to use a calculator. Okay? So because you want to build the sense of the numbers. Okay, how about here? What's the root of 8? Huh? 2, yes. And then what's 2 to the 4th? 2 to 2 cubed is 8. And then 2 to the 4 is 16. Okay. Do you know what's 2 to the 5th? 32. 2 to the 6th. 54 to the 7th. 128 to the 8th. 256. Yes. Okay, so practice those. Okay, any questions about this problem? All good, everybody? Yeah, so by the way, when you use this rules, your calculator. So everybody tries to plug in your calculator. So sometimes your calculator, when your base is a negative number, it says error. So I want to see if your calculator is error. So parentheses, negative 8 over 27, a negative. Over 27, parentheses, to the negative 4. Yes. So you can use that. Now you can use your calculator to check the work. Okay. But in your homework, do it without calculator first. Then use calculator to check your work. Okay. Very good. So we keep going. Okay. Next, I want to introduce exponential function. So we learned power function before. Power function like x cubed or polynomials. Do you see x's in the base and the exponent is a constant, right? So those polynomials, our base is x, and then our exponent is numbers. But exponential function is a function of the form of b to the x, where the base is a number. So you see b is constant, and x is on the exponent. So this is the main difference between polynomial and exponential function. Your x now is in the exponent for the exponential function. Okay? And then your base, we have requirement for the base. The base is positive, and the base is not equal to 1. Why? Because if the base is negative, think about it. If the base is negative 1, but your x is a variable. Okay, your x is any real numbers. If you take x's 1/2, well then you will end up getting -1 to the 1/2. This is square root of -1, and this is a complex number. Okay, so therefore, in order to have the square roots make sense, and we're working with real numbers, we must force the base to be greater than 0 to avoid such case. Okay, everybody? And so b has to be bigger than 0. And why b is not 1? Think about it. 1 to the whatever power is just 1. So you only get a constant function, not quite interesting. Okay? That's why exponential function, we don't want it to be a constant function. So we want the base b to be positive and it's not equal to 1. Alright. So we have two cases. Case when the base b is bigger than 1. Case 2, when the base b is between 0 and 1. Okay, let's look at the first case. Is that okay when we go over the notes with answers? Because like I said, we are 2 lectures behind. So for the theory, I will go over the notes with answers. And for the examples, I will do it by hand. Okay, everybody? If you have questions, please ask me. Okay, first case, if b is greater than 1. Let's use some example. Let's use 2. 2 is bigger than 1, right? So let's look at 2 to the x. Well, remember when we draw a graph, you want to draw a table, you have the x value here, and you have the y value here. X, let's take 0. Yeah, you want to plot some points near the origin, right? You plug in x is 0. Whoa, what's 2 to the 0? 1. 2 to the 0. Whatever number raised to the 0 is 1, right? So therefore, you plug in 0, 1 here. Yes, everybody, look at me, look at me. Yes, we plug in 0, we get 1. That's why we get this point. And then when you plug in 1, 2 to the 1 is 2, right? So here we plug in 1, 2 to the 1 is 2. And how about we plug in x is 2? 2 squared is 4. You see this one is 4. How about we plug in x is minus 1? 2 to the negative 1 is 1 half. Therefore, negative 1, 1 half is this point. So we get an exponential function. Goes like that. So now our library of functions. We have one more, like that. Okay, everybody move your hand, like that. Yes. Okay, properties. Domain. Remember, domain is the set of x values. You have a sum here and you project down on the x-axis. Do you see the domain is all real numbers? Because this side, it goes to minus infinity. And this side, it goes to positive infinity. Okay, so our domain is all real numbers from minus infinity to infinity. And then the range. Range, you project on the y-axis. Do you see this side, it goes to infinity? And this side is getting closer, closer, closer to 0, but it never reached 0. That's why for the range is from 0 open to infinity. Right, everybody? Okay. And do you see it's going up? So it's increasing all the time. Exponential function is increasing all the time. Y-intercept. Do you see the y-intercept is this point 0, 1? So this is the y-intercept. Do we have x-intercept? No, because it's approaching to the x-axis, but it never touched. So we don't have any x-intercept. Okay? Do we have horizontal asymptote? Yes. Do you see we're approaching to this line? The x-axis corresponds to y equal to 0. So horizontal asymptote is y equal to 0. Do we have vertical asymptote? No. So no vertical asymptote. Okay? So this is the first case when the base b is greater than 1. Okay, and then it all looks like this graph. It's increasing function. Okay, case 2. What happens if b is between 0 and 1? Let's use an example, the 1 half. Okay? And we plug some points. We plug in 0. 1 half of the 0 is 1. Yes? And then you plug in 1. Oh, you get 1 half of the 1. It's 1 half. See? You plug in 1, you get 1 half. How about you plug in minus 1? 1 half to the minus 1. You remember minus 1? You flip it. You get reciprocal. Reciprocal of 1 half is 2. Yes, everybody? you get -1, 2. When you connect those points, you see going down is a decreasing function, right? And you can see the domain when you project on the x-axis. It's all real numbers. The shadow, all real numbers, right? The domain is all real numbers. How about the range? You project on the y-axis. Do you see this side? It goes to infinity. And then this side is approaching to 0, but it never equals to 0. That's why it's 0 open to infinity. Yes. And you see it's going down as t increases. So this is decreasing. The function is decreasing. Okay? And do we have y-intercept? Yes. The y-intercept is also 0, 1. Everybody? And do we have x-intercept? No, it's getting closer, closer, closer to the x-axis, but it never touched the x-axis. So we don't have x-intercept. Do we have vertical asymptotes? No, right? Do we have horizontal asymptotes? Yes. The x-axis, which is y equals to 0. Okay. Now look at this graph and compare it this graph. Can you see this graph? And when you flip it over the y-axis, right? When you flip it over, do you see when you use this graph flip it over and you get this graph? Do you see that, everybody? Why? Because 1/2 to the x is like 2 to the -1 to the x. And you can multiply the exponent, you get 2 to the -x. And from 2 to the x to 2 to the -x, do you remember our transformation? If you have your xy and then you put a minus sign in front of the x, this is reflection what? Over the y-axis. Exactly. That's why this graph is the reflection of this graph over the y-axis. So reflection. Okay. So this is the property of exponential functions. Any questions? Yes.
Like, I see on like your table where you plugged in like each of your values, and then you got like your other values. How did you know which values like you wanted to use though? Like I see you used 1 and then 2 and then -1.
Yeah, we just pick easy numbers. Like 0 is easy, 1 is easy, -1, and then 2, and then -2. So you just plus some numbers, and then you connect those points smoothly, then you get the graph. Yes, we just pick some numbers. Okay, good. Of course, we don't pick 0.5. It's hard to compute, right? You need to use your calculator. 1 is easier to compute. Okay, next one. Useful facts for solving equations involving variables in the exponents. Suppose b is positive and b is not 1, then we have the following. If b to the x equals b to the y, then x equals y. This property is true for all the one-to-one functions. Okay, if you can remember one-to-one function, the definition was that, yes, so f is one-to-one if f of a equals f of b implies a equals to b. So therefore here, this is like f of x, which is b to the x, equals f of y, so b to the y. Therefore, we have x equals to y. So this is the definitions of one-to-one function. And do you remember one-to-one function? It passes through the horizontal line test. Yeah? Look at this. Look at the graph. If you use any horizontal line to intercept it, you only get at most one intersection point. Right? Also, this graph, you use any horizontal line to intercept it, you only get one, at most one intersection point. So exponential function is 1 to 1. So therefore, we have this property. Okay, so as long as you make sure the base are the same, then you just set the exponents equal to each other. Okay, everybody? So let's do examples. Okay, so solve the following problems. Okay, so that's why this kind of problem, you gotta be very familiar with the numbers. What is 32? And we want to have the same base here. So we want the base to be 2. 32 is 2 to the 4. 5. Okay, let's review again. 2 squared. 4. 2 cubed. 8. 2 to the 4. 16. 2 to the 5th. 32. 2 to the 6th. 64. 2 to the 7th. 128. 2 to the 8th. 256. Right? So 32 is 2 to the 5th. Good. And then by this fact, if we have the same base, then we can just set the exponent equal to each other. Okay? So x equals 5. Right, everybody? Okay. On the other side, 9. Let's take the easiest base. 9 is what? 3 squared. Okay, 9 is 3 squared and then raised to the t. Do you agree, everybody? How about on the right-hand side? So do you see 27 is in the denominator? If you want to move it up, what do? Raise to the -1. And what is 27? You want to get an easier base. What's the easier base? 3. 27 is 3 to the what? Yeah, very good. Yes, right, everybody. 3 cubed. So 3 cubed is 27 raised to the -1. Right? Okay. See, you're going to be familiar with the numbers. The calculator does not help. Right? Okay, so, what do we do to the exponents? We multiply, right? So this is 3 to the 2t. How about on this side? What do we do to the exponents? Multiply. Yeah, 3 to the -3. Do you make sure we have the same base? Then we can set the exponents equal to each other. So 2t is -3. What's t? Yes, so both sides divided by 2, we get t is -3/2. Is that okay, everybody? All right. Now, keep going. Part C, I will let you to do at home. Okay. Let's do part D. What is 8? 2 cubed. Yes, everybody, 2 cubed. So 2 cubed is 8 to the z plus 1. What is 32? 2 to the 5th, yes. And then you see this is 32 times, sorry, this number is 32 times, what is square root of 2? 2 to the 1/2. Right, everybody? Square root is to the 1/2. Right? The cube root is to the 3rd. Right, everybody? Okay. Alright. So we have, okay, what do we do to the exponent? Multiply. And by the way, this is my 2. This is my C. Make sure your C does not look like the 2. So 2 to the 3 times Z plus 1. Okay. How about on the right hand side? What do you do to it? Multiply or add? Huh? We add them, yes. 5, okay, so 2 to the 5 plus 1 half. Okay, keep going. What is 5 plus 1 half? 5 is what over 2? 10 over 2. 10 plus 1. 11 over 2. Good. See, we have the same base. Now we set the exponents equal to each other. How do you solve a z? Distribute, or you can divide it by 3 on both sides, right? If you divide it by 3, then you don't need to distribute. Okay, divided by 3. Then we have z plus 1 is, what's that? Divided by 3, that means you want to put the 3 in the denominator. Is that okay, everybody? You divided by 3, so you put it in the denominator. What's 2 times 3? 6. Okay, so divided by 3 is like you put 3 in the denominator. Is that okay, everybody? So that is 6. Okay, now what do we do? Subtract 1 on both sides. So z is 11 over 6 minus 1. 1 is like 6 over 6. Be careful, everybody. Don't just put 10 over 6. You not just subtract 1 from the numerator, okay? You're subtracting 1. So, and you take the common denominator is 6. 11 minus 6 is what? 5 over 6. So z is 5 over 6. So this part is harder. Hard to do, everybody? Okay, good. So keep going. All right. Questions. Why can't we use this method to solve equation like 2 to the minus x equals 3? The problem is, this is like 2 to the negative x. This is like, what, 3 to the 1? They don't have the same base. So we cannot use this method to solve equations like that if they don't have the same base. Right? And we will introduce in the next section. The logarithm function can help us to solve such equations. Okay, and then next, let's talk about the graph. Okay, graph each of the following functions, starting with the graph of 2 to the x and applying the correct transformations. Let me make the problem more interesting. Okay, let's do a harder one. So let's do minus 3 times 2 to the x plus 2 and 4. Okay, let me make it more interesting. So your exam problem look like that. Okay, so what do you do? Remember what's the order of transformations? What's the first one? Shift, left, or right. Left is plus or minus. Plus. And the right is minus. The second one. Reflects over the y-axis. The third one. Reflect over the x and stretch. The fourth one. Straight up and down. Okay. Look at this. Our parent function. Well, our parent function is always the exponential function, right? And the base is 2. You see? The base is 2. Okay. So step 1. Write down the parent function. 3 key points. The 3 key points are 0. When you plug in 0, 2 to the 0 is 1. And when you plug in 1, 2 to the 1 is 2. Yes, everybody? And when you plug in minus 1, 2 to the minus 1 is 1/2. So we have those 3 key points. So far, so good? Everybody? Okay, so step 1, you start with the parent function. And then, okay, tell me, do we have shift left or right? Do you have x plus or minus a number in the expression? You have x plus or minus number? Yes. Why? So we have 2 to the x plus 2. What is the transformation? Left or right? Left. 2 units. Right, everybody? So look at those 3 key points. Okay, look at those 3 key points. This point, you shift to the left 2 units. What is the new point? It'll be, what's that point? Minus 1 and 2. Right, everybody? Yes? Okay, how about the next point? If you shift to the left 2 units, you get what? Minus 2 and 1. Yes? And the next point, you shift to the left 2 units, you get what? Minus 3 and 1/2. And then you connect them. So we have 3 key points. Okay, so for those 3 key points, you shift to the left 2 units. Is that okay, everybody? Yeah, take notes, take notes. All right, what is the next transformation? We have, do you see a minus sign in front of x? No. Do you see a minus sign in front of the whole function? Yes. Right. So negative 2 to the x plus 2. This is reflected over the x-axis. Okay, what happened? You see this point? Reflection. It goes down. So it is what? I don't want. Where is it? Okay, so 1, 2, 3, negative 3, and it was 1/2. Now it become minus 1/2. Yes, everybody? And then this point reflects. So it is negative 2 and what? Negative 1, yeah? And this point, it becomes negative 1 and negative 2. And we connect them. So this is reflection over the x-axis. What is the next one? Stretch. So we have negative 3 times 2 to the x plus 2. Vertical stretch by a factor of 3. Okay, what does that mean? Okay, we don't do part B, okay? We do a harder problem. So this means what? You Your x remain the same, but your y, you multiply by 3, right? Okay, so let's draw it. Okay, let me make it smaller. Okay, how would that change? So this point, it was -3 and -1/2. Your x remain the same, so still -3. So your y is -1/2 times 3 is -3/2, right, everybody? And what's -3/2? It's like -1.5, right? Which is here. So this is -3/2. This is -1, -2, -3. Okay, -3 here. So -3/2 is here. How about the next point? You see x is -2, but the y it was -1. When you multiply by 3, you get -3 here. Okay. Next one. -1. It was -2. When you multiply by 3, you get what? -6. Oh, -6 here. And then you connect those 3 points together. Okay, everybody? So you draw those 3 points. And then you connect them smoothly. Okay, what is the last one? So what's that? What's the last one? Yeah, shift up 4 units. So -3 times 2 to the x plus 2 at 4. We shift up 4 units. Okay, let's see what happened. So this point, it was -3/2. You shift up 4 units. What do you get? What is 4 minus 1.5? What? 4 minus 1.5? 2.5, right, everybody? So 2.5 right here. Okay, next point. It was -3. You move up 4 units. You get what? One. Good. Next one. It was -6. You shift up 4 units. You get what? 2. Sorry, you mean -2, right? Yeah, -2 here. Okay. Now we can. Okay. So here, there's one thing we miss. What's that? What's the thing we miss? We need to draw the horizontal asymptotes. So at the beginning, the horizontal asymptote is the x-axis. Okay. When you do the shift, will your horizontal asymptote change? When you shift the whole thing to the left, will your horizontal asymptote change? No. And then when you with flash over the x-axis, will your horizontal asymptote change? No. See? You put the y, but it was 0, so it remained the same. Then here, when you multiply by 3, will your horizontal asymptote change? No. When you move up 4 units, will your horizontal asymptote change? Yes. And it is at y equals to 4. So horizontal asymptote is y equals to 4. Okay? So something new here. For exponential function, you need to write down the domain and range. Do you see your domain is the x values is all real numbers? And your range is -infinity up to 4. Okay, your y value of minus infinity up to the 4. So this is the extra thing you need to know for exponential function. Okay? Not only the graph and translation, but also the horizontal asymptotes and domain and range. Have a nice day.
Thank you.
Thank you.